Hi folks, in this video we're going to go through the process of normalizing wave functions. We'll start by normalizing the wave functions for the particle in the box. To remind you, our criterion for normalization was that the wave function times its complex conjugate integrated over all space should be set to equal 1. That is normalization. So to start out this problem, we need to remind ourselves of what was psi of x for the particle in the box. That was given to us as a sine n pi x over a. So here's the wave function that is the solution for the particle in the box. We need to normalize it by plugging it into this expression here, integrating over all space and setting that quantity equal to 1. So let's plug in our particle in the box wave functions. What would that look like? That would mean that 1 is equal to the integral of a sine n pi x over a times a sine n pi x over a dx. Notice that the complex conjugate here is just the function again. There's no imaginary component. If you were to rewrite this another way, you would maybe say that it is a plus ib times a minus ib dx, where we flip the sign of the imaginary component to make it the complex conjugate. This wave function doesn't have any imaginary component, so it just looks like the function squared. So that is set equal to 1. Notice to integrate, we need to integrate over all space. For the particle in the box, we don't need to do all space, or a better way to say it maybe is all space is from 0 to a. Remember, here's 0 to a for our particle in the box wave functions. Those are the boundary conditions. So here's the n equals 1, n equals 2, n equals 3 level. We really need to only integrate from 0 to a. I'm going to rewrite this equation one more time to kind of simplify it. That would be, or combine terms, I guess. That would be a squared sine squared of n pi x over a dx. So we simply need to apply a standard integral to this, and our goal is to solve for this capital A term to make this mathematical statement true. There is a value for A that makes the integral of the wave function times its complex conjugate equal to 1. That's what we're solving for. So here I've written the function again. Remember, we're solving for A. We need to apply a standard integral from a standard integral table. I've given you the standard integral that we need here for sine squared. Now we're going to apply that standard integral to this particular expression. So I'm going to write it out in several different ways just to show all the possible steps. First, I'll factor out the a squared because we're not going to integrate with respect to that. And I'm going to rewrite this expression using the values we have here for our integral. Notice that the standard integral is of the form bx. For us, n pi over a is equal to b. So n pi over a is equal to b in this particular equation. So I'm going to rewrite the standard integral here. And that would be 1/1 x minus 1 for n pi over a sine 2 times n pi over a x, and then we need to evaluate that from 0 to a. So I've simply replaced all the b's in the standard integral with n pi over a. Now I need to write out two terms, one for the 0 and one evaluated at a. So 1 is equal to a squared. And here I'll make parentheses of different colors to make it easier to follow. That would be 1 over 2. Now, everywhere I have an x, I'm going to substitute in an a value. So a, I'll color code this. A is going to be red, and 0 is going to be blue in terms of the terms I'm going to write out here. So it's 1/2 a plus 1 over 4 n pi all over a sine Notice that is the first term in the standard integral where I've replaced all the x values with a's. Now I'm going to write out the second term, the final minus the initial. The initial term where all the x's are substituted with zeros. So that's 1 over 1/2 times 0 for n pi a and here's my x, which is now a 0 for this term. And I'm going to close parentheses and put the square parentheses back. Notice that using the standard integral, we've simply written out our final minus our initial terms based on the domain over which we're integrating. Okay. So now we can simplify several of these. Notice that this term is 0. The sine of 0 is 0. And the sine of n pi is 0. So our simplified expression is a squared 1/2 a. Remember, our goal was to solve for capital A, so we can rearrange that algebraically and get a is equal to the square root of 2 over a. Rewriting our wave function, our final answer is we're replacing this a sine n pi x over a. We're replacing this a with the new normalization constant we've just determined. So that is 2 over a sine n pi x over a. There is our new normalized particle in the box wave function. If we take that function and multiply it by itself and integrate from 0 to a, we will get a value of 1.